just wanting to go over section 7.2, the key ideas for the chapter, right before I show you how to do graphing using the graphing calculator. So it says a parabola is defined by the equation ax squared plus bx plus c has the following characteristics. So remember, I had said that if a was smaller than 0, the parabola opens down. It's a frown. And if a is larger than 0, so a positive number, being positive, it'll open up, which is a smiley face. The parabola is symmetrical about a vertical line called the axis of symmetry. So the axis of symmetry is what cuts your picture into two even pieces. So it should be a reflection of each other, one on the other side of the other. So this is your axis of symmetry. The parabola is symmetrical about the axis of symmetry through the vertex. So the vertex is your minimum value, or if your picture is opening down, then it's your maximum value. Your vertex is either your highest or your lowest point. In the need to know section, for all quadratic functions, the domain is the set of real numbers and the range is a subset of real numbers. So what that means is, if you're looking at the domain, you're always looking at your x values. So these parabolas, they can extend on and up and go as wide as we don't know. So if you're talking about your domain, usually for a parabola, you write it as all real numbers. XER. And for your range, it would also be all real numbers. So your range would be YER. Oh, that's terrible. YER. And when a problem can be modeled by a quadratic function, the domain and range of the function may need to be restricted. So if we're talking about a golf ball being hit in the air, it's not usually going to go into the negatives. The golf ball isn't going to go deep into the ground. So usually you would restrict your domain and range to just be greater than 0. So keep in mind your domain and range is all real numbers for x, and your range is all real numbers for y. So if we go to example 3, I'll show you how to do this using the graphing calculator. So you'll turn your graphing calculator on and you'll hit your y equals. If there's anything in there, you can just hit clear and erase all your information. So for this, we want the equation y equals x squared plus x minus 2. We want to find the y-intercept, the x-intercept, the axis of symmetry, the vertex, and the domain and range. So first I would enter, I will hit x with my squared button, plus another x, subtract 2. And then I'll go up to this top button and I will hit graph. If your graph is not in standard form, the easiest thing you can do is you can hit zoom and go down to 6 for your standard window and hit enter. That'll get you to your standard window. So from here, we can tell that the parabola is opening up. We will be able to find our x and y intercepts, the axis of symmetry, the coordinates of the vertex, and we can see that the domain is XER and the range is YER. So if we want to find our y-intercept, what we can do is we can hit the trace button. And right when we hit the trace button, it shows us if x is 0, y is equal to -2. So that is our y-intercept. And we can move the arrows and get along the x-axis to find our x-intercepts. So what I do is once I'm there, it looks like I'm in a good spot, but I can hit my zoom button again. And if I hit 2 for zoom in and enter, it'll zoom in on the spot where I'm at. And now I notice I'm a little bit off, so I'll move over and I can see my x-intercept is 1. And then I'll go back to zoom standard, which was 6, and enter. And I will hit my trace button, and I'll trace back up my parabola, and I'll try to zoom in on my picture at this point, and it will show me my x-intercept is -2. Okay, so now we've found our y-intercept to be -2. We have an x-intercept of -2 and an x-intercept of 1. If we want to find our axis of symmetry, the equation of it, we'll go back to our standard form and we will hit trace and we'll cruise down till we get to what we think is the bottom of the parabola, where we can hit zoom and hit zoom in. This way we will be able to find the vertex of this equation, and it looks like the vertex is at -0.5 and -2.25, and therefore our axis of symmetry will be at x is equal to -0.5. So now, by using the graphing calculator, we have found all of these points.